Question 1. Upon reviewing a sudden and significant degradation in quality of service for a critical customer-facing application, what is the most appropriate initial step to systematically assess the risk and identify the root cause of the issue? Option A. Conduct a comprehensive analysis of network performance metrics, traffic patterns, and device logs across all potentially impacted network segments, correlating events to pinpoint anomalies and potential failure points. Option B. Rely on user-reported symptoms and prioritize troubleshooting efforts based on the loudest complaints, without extensive data collection. Option C. Immediately initiate a rollback of the most recent network configuration changes, assuming they are the direct cause of the CoS degradation. Option D. Dispatch field technicians to physically inspect all network hardware in the affected path, prioritizing replacements based on age and perceived reliability. Correct answer is A. Conduct a comprehensive analysis of network performance metrics, traffic patterns, and device logs across all potentially impacted network segments, correlating events to pinpoint anomalies and potential failure points. Explanation: Scenario analysis. This scenario presents a professional challenge in network management where a critical service outage has occurred. The challenge lies in identifying the root cause of the quality of service, CoS, degradation, and implementing a timely resolution while adhering to operational procedures and regulatory expectations for service availability. The pressure to restore service quickly must be balanced with the need for a thorough and accurate diagnosis to prevent recurrence. The complexity of modern IP networks, with multiple interacting components and potential failure points, further amplifies this challenge. Correct approach analysis. The correct approach involves a systematic and data-driven risk assessment. This begins with gathering comprehensive logs and performance metrics from all relevant network elements, routers, switches, firewalls, CoS policy enforcement points, that could impact the affected service. Analyzing these data points for anomalies, error messages, or deviations from baseline performance is crucial. Correlating events across different devices and timeframes helps pinpoint the most probable cause. This methodical process aligns with best professional practices for incident management and CoS assurance, as it prioritizes evidence-based decision-making. By understanding the specific CoS mechanisms and their configuration, e.g., queuing, policing, shaping, marking, and correlating their operational status with the observed service degradation, network engineers can effectively identify the risk factors and their impact. This approach is implicitly supported by general principles of network operational excellence and the need to maintain service-level agreements, SLAs, which are often underpinned by regulatory expectations for service reliability. Incorrect approaches analysis. One incorrect approach is to immediately assume a hardware failure without sufficient evidence. This bypasses a critical risk assessment phase, potentially leading to unnecessary hardware replacement, significant downtime, and failure to address the actual software or configuration issue. This is a regulatory and ethical failure, as it demonstrates a lack of due diligence in troubleshooting and can lead to prolonged service disruption, violating implicit or explicit service availability requirements. Another incorrect approach is to rely solely on anecdotal reports or the most recent configuration change, without verifying the impact through data analysis. While recent changes can be a strong indicator, they are not always the root cause. This approach risks misattributing the problem, wasting valuable troubleshooting time, and failing to implement the correct fix. Ethically, it represents a failure to apply a rigorous, evidence-based methodology, potentially leading to continued service degradation and customer dissatisfaction, which can have regulatory implications if SLAs are breached. A third incorrect approach is to implement a broad, untested solution across the network without a targeted risk assessment. This shotgun approach can introduce new problems, further destabilize the network, and delay the identification of the true root cause. It fails to demonstrate a professional understanding of network interdependencies and the principle of least impact when troubleshooting. This can lead to regulatory scrutiny for failing to manage the network responsibly and maintain service integrity. Professional reasoning. Professionals should adopt a structured incident response framework that emphasizes a data-driven risk assessment. This involves 1. Clearly defining the scope and impact of the incident. 2. Gathering all relevant diagnostic data from network elements. 3. Analyzing this data to identify potential causes and their associated risks. 4. Prioritizing troubleshooting steps based on the assessed risks. 5. Implementing targeted solutions and verifying their effectiveness. 6. Documenting the incident, root cause, and resolution for future reference and continuous improvement. This systematic process ensures efficient problem resolution, minimizes service disruption, and upholds professional standards of network operation and CO-S management. Question 2. The efficiency study reveals that a core network segment is experiencing a sustained increase in packet loss, impacting the performance of critical voice and video services. Which of the following risk assessment approaches would be most effective in addressing this issue while adhering to Alcatel Lucent CO-S guidelines and regulatory expectations for service continuity? Option A. Immediately reconfigure CO-S policies across all network segments to prioritize voice and video traffic universally, assuming the issue is a general network-wide congestion problem. Option B. Focus solely on increasing buffer sizes on network devices within the affected segment to absorb the excess traffic, without investigating the underlying reasons for the increased loss. Option C. Conduct a comprehensive root cause analysis of the packet loss, prioritizing potential sources of congestion, hardware malfunctions, and configuration errors within the affected segment, and then implement targeted remediation based on the identified highest probability causes. Option D. Monitor the packet loss for an extended period to determine if the trend is temporary before initiating any corrective actions. The correct answer is C. Conduct a comprehensive root cause analysis of the packet loss, prioritizing potential sources of congestion, hardware malfunctions, and configuration errors within the affected segment, and then implement targeted remediation based on the identified highest probability causes. Explanation. The efficiency study reveals that a critical quality of service, CO-S, parameter, specifically packet loss, is exceeding acceptable thresholds on a core network segment. This scenario is professionally challenging because it directly impacts service delivery to end users, potentially leading to customer dissatisfaction, revenue loss, and reputational damage. The challenge lies in accurately identifying the root cause of the increased packet loss and implementing effective remediation strategies within the constraints of operational network stability and regulatory compliance. The correct approach involves a systematic risk assessment focused on identifying the most probable causes of packet loss and prioritizing mitigation efforts based on their potential impact and likelihood. This aligns with best professional practice by ensuring that resources are allocated efficiently to address the most significant risks first. In the context of Alcatel Lucent CO-S frameworks, this means leveraging diagnostic tools and methodologies to pinpoint issues such as congestion, faulty hardware, misconfigurations, or upstream network problems. A proactive and data-driven approach to risk assessment is crucial for maintaining network integrity and meeting service-level agreements, SLAs, which are often subject to regulatory oversight. An incorrect approach would be to implement a broad, unvalidated fix without a thorough risk assessment. For instance, randomly adjusting CO-S policies across the entire network without understanding the specific segment experiencing the issue could lead to unintended consequences, disrupting other services and potentially violating CO-S regulations by negatively impacting other traffic classes. Another incorrect approach is to ignore the issue, hoping it resolves itself. This is a clear ethical and professional failure, as it demonstrates a lack of diligence and responsibility in maintaining service quality, which can have severe regulatory implications if SLAs are breached. Furthermore, a reactive approach that only addresses the symptom rather than the root cause, such as simply increasing buffer sizes without investigating the underlying congestion source, is also professionally unsound. It fails to address the fundamental risk and is unlikely to provide a sustainable solution, potentially leading to recurring issues and regulatory scrutiny. Professionals should employ a decision-making framework that prioritizes a structured risk assessment. This involves 1. Defining the problem and its impact, e.g., increased packet loss affecting specific services. 2. Identifying potential causes and their associated risks. 3. Evaluating the likelihood and impact of each risk. 4. Prioritizing risks based on this evaluation. 5. Developing and implementing mitigation strategies for the highest priority risks. 6. Monitoring the effectiveness of the implemented solutions and iterating as necessary. This systematic process ensures that actions are informed, targeted, and aligned with both operational efficiency and regulatory requirements. Question 3. Examination of the data shows a gradual increase in packet loss on a critical network segment over the past 48 hours, though current metrics remain within the upper bounds of the defined quality of service (QoS) thresholds. Network engineers are considering several immediate actions to address this trend. Which of the following represents the most prudent and professionally responsible approach to mitigating this potential service degradation? Option A. Immediately deploy a more aggressive QoS policing policy across the entire network to preemptively reduce traffic volume on all segments, assuming this trend will worsen. Option B. Ignore the trend as current performance metrics are still within acceptable limits, and wait for a more significant degradation before initiating any action. Option C. Conduct a targeted diagnostic test on the affected segment to isolate potential hardware or configuration issues, and if a likely cause is identified, implement a minimal, reversible configuration adjustment to observe its impact. Option D. Escalate the issue to the senior network operations team for immediate investigation, providing them with the raw performance data without any initial analysis. The correct answer is C. Conduct a targeted diagnostic test on the affected segment to isolate potential hardware or configuration issues, and if a likely cause is identified, implement a minimal, reversible configuration adjustment to observe its impact. Explanation. Scenario analysis. This scenario presents a challenge in network management where a potential service degradation is identified, but the root cause is not immediately obvious. The professional must balance the need for proactive problem resolution with the risk of implementing ineffective or disruptive changes. The pressure to maintain service quality, as mandated by service-level agreements, SLAs, and regulatory expectations for reliable telecommunication services, adds to the complexity. A hasty or unverified solution could lead to further service issues, customer dissatisfaction, and potential breaches of contractual obligations or regulatory noncompliance. Correct approach analysis. The correct approach involves a systematic risk assessment to identify the most probable causes of the observed performance anomaly and to prioritize mitigation strategies based on their likelihood of success and potential impact. This aligns with best practices in network operations and quality of service management, which emphasize data-driven decision-making and a phased approach to troubleshooting. By analyzing historical data, traffic patterns, and system logs, the network engineer can form hypotheses about the cause. Then, implementing a targeted, low-impact test or configuration change to validate the hypothesis before a full-scale remediation is a prudent step. This minimizes disruption and ensures that resources are applied effectively. This methodical approach is implicitly supported by regulatory frameworks that expect service providers to operate with due diligence and to have robust processes for maintaining service quality. Incorrect approaches analysis. Implementing a broad, unverified QoS policy change without a clear understanding of the root cause is a significant regulatory and ethical failure. It risks negatively impacting legitimate traffic, potentially violating the spirit of fair access and service provision. Such an action could lead to customer complaints and SLA breaches, as it's not based on a reasoned assessment of the problem. Disregarding the anomaly because it falls within acceptable historical variance without further investigation is also problematic. While the current performance might be within bounds, the observed trend could indicate an emerging issue that, if left unaddressed, will eventually lead to a significant service degradation. This passive approach fails to meet the proactive obligations expected of a service provider to maintain consistent quality and could be seen as a failure to exercise due care. Immediately escalating the issue to a higher support tier without performing any initial diagnostic steps is inefficient and can lead to unnecessary delays and resource misallocation. While escalation is a part of problem resolution, it should be a step taken after reasonable initial investigation, not as a substitute for it. This could be viewed as a failure to adequately manage resources and a lack of professional diligence in addressing the immediate concern. Professional reasoning. Professionals should adopt a structured problem-solving methodology. This begins with clearly defining the observed issue and gathering all relevant data. Next, a hypothesis generation phase, informed by data analysis, is crucial. This is followed by a risk assessment of potential solutions, prioritizing those with the highest probability of success and lowest risk of adverse impact. Implementation should be phased, starting with low-impact tests or changes, and closely monitored. Continuous evaluation and adjustment of the strategy based on new data are essential. This iterative process ensures that decisions are informed, effective, and compliant with service obligations. Question 4. Performance analysis shows a consistent upward trend in network traffic volume across several key service paths, with occasional, short-lived spikes exceeding historical averages. While no current service degradation has been reported by customers, there is a discernible increase in packet loss and latency metrics during these peak periods. What is the most appropriate risk assessment approach to ensure sustained quality of service? Option A. Continue monitoring current metrics and only initiate a risk assessment if customer complaints regarding service degradation are received. Option B. Focus solely on addressing the observed packet loss and latency spikes with immediate configuration adjustments without a broader risk evaluation. Option C. Implement a comprehensive risk assessment to identify potential congestion points, evaluate the impact of traffic surges on critical services, and develop proactive mitigation strategies such as dynamic traffic shaping or capacity upgrades. Option D. Assume that the current network infrastructure can inherently handle future traffic growth and that the observed spikes are temporary anomalies. The correct answer is C. Implement a comprehensive risk assessment to identify potential congestion points, evaluate the impact of traffic surges on critical services, and develop proactive mitigation strategies such as dynamic traffic shaping or capacity upgrades. Explanation. Scenario analysis. This scenario presents a professional challenge because it requires a proactive approach to potential service degradation rather than a reactive one. The challenge lies in identifying and mitigating risks before they impact end users, which is crucial for maintaining customer trust and adhering to service-level agreements, SLAs. The pressure to maintain high availability and performance in a complex network environment necessitates a robust risk assessment framework. Correct approach analysis. The correct approach involves a systematic identification, analysis, and evaluation of potential risks to quality of service, (QoS). This aligns with best professional practices in network management and aligns with the spirit of regulatory frameworks that emphasize service reliability and customer protection. By proactively assessing risks, such as potential congestion points, equipment failures, or configuration errors, network engineers can implement preventative measures. This demonstrates due diligence and a commitment to maintaining the agreed-upon QoS levels, thereby fulfilling contractual obligations and regulatory expectations for service continuity. Incorrect approaches analysis. One incorrect approach is to solely rely on reactive troubleshooting after a QoS issue has been reported. This fails to meet the proactive requirements of QoS management and can lead to significant service disruption, customer dissatisfaction, and potential breaches of SLAs. From a regulatory perspective, this reactive stance can be seen as a failure to implement adequate risk management controls, potentially violating guidelines that mandate service availability and performance monitoring. Another incorrect approach is to focus only on the most visible or frequently occurring issues without considering less frequent but potentially more impactful risks. This narrow focus can leave the network vulnerable to unforeseen problems. Ethically, this approach is deficient as it does not provide comprehensive protection for service quality. A third incorrect approach is to dismiss potential risks based on anecdotal evidence or a lack of immediate observable impact. This overlooks the interconnected nature of network components and the potential for cascading failures. Such an approach demonstrates a lack of thoroughness and can lead to significant unmitigated risks, which is professionally unsound and potentially non-compliant with any regulatory expectations for risk mitigation. Professional reasoning. Professionals should adopt a structured risk assessment methodology. This involves 1. Identifying potential QoS risks across all network layers and services. 2. Analyzing the likelihood and impact of each identified risk. 3. Prioritizing risks based on their potential severity. 4. Developing and implementing mitigation strategies for high-priority risks. 5. Regularly reviewing and updating the risk assessment as the network evolves. This systematic process ensures that resources are allocated effectively to address the most critical threats to QoS, fostering a culture of continuous improvement and proactive service assurance. Question 5. The audit findings indicate that the current quality of service, QoS, management process within the organization is heavily reliant on responding to customer-reported issues rather than proactively identifying potential service degradations. This approach has led to intermittent but noticeable performance impacts for users that were not flagged by internal monitoring systems until after multiple complaints were received. Which of the following represents the most effective and professionally sound approach to address this audit finding and improve the organization's CoS management? Option A. Implement a comprehensive CoS monitoring strategy that includes continuous performance analysis of key network elements and service metrics, coupled with trend analysis to predict potential issues before they impact users. Option B. Focus solely on ensuring that all reported issues are resolved within the defined service level agreement (SLA) parameters, regardless of the underlying network health. Option C. Develop a policy that mandates the immediate resolution of any reported CoS issue within a strict timeframe, without requiring extensive root cause analysis. Option D. Increase the staffing levels within the customer support team to expedite the resolution of incoming CoS-related complaints. Correct answer is A. Implement a comprehensive CoS monitoring strategy that includes continuous performance analysis of key network elements and service metrics, coupled with trend analysis to predict potential issues before they impact users. Explanation: the audit findings indicate a potential deviation from best practices in quality of service, CoS management, specifically concerning the proactive identification and mitigation of service degradation. This scenario is professionally challenging because it requires a nuanced understanding of CoS principles beyond mere reactive troubleshooting. The pressure to maintain service levels while managing operational costs necessitates a strategic approach to CoS, rather than a purely incident-driven one. The correct approach represents best professional practice because it aligns with the proactive and preventative nature of effective CoS management, as outlined in industry best practices, and implicitly supported by regulatory expectations for service providers to deliver reliable services. By focusing on continuous monitoring and trend analysis, potential issues are identified before they impact end users, minimizing service disruptions and customer dissatisfaction. This approach demonstrates a commitment to service excellence and operational efficiency, which are key tenets of responsible service provision. An incorrect approach that relies solely on customer complaints for CoS issue identification is professionally unacceptable. This represents a failure to meet the implicit regulatory expectation of providing a stable and reliable service. It is reactive, inefficient, and leads to a poor customer experience, potentially resulting in reputational damage and regulatory scrutiny for failing to uphold service commitments. Another incorrect approach that prioritizes immediate fix of reported issues without root cause analysis is also professionally deficient. While addressing immediate problems is necessary, neglecting root cause analysis means the underlying issues will likely recur, leading to a cycle of reactive firefighting. This is inefficient, costly in the long run, and fails to demonstrate a commitment to sustainable service quality, which is a hallmark of professional CoS management. A further incorrect approach that focuses only on meeting service level agreements, SLAs, without considering the underlying network health is problematic. While SLAs are critical contractual obligations, a purely compliance-driven approach can mask underlying performance degradations that, while not yet breaching SLAs, are negatively impacting user experience and could lead to future SLA breaches. Best practice involves understanding and managing the factors that contribute to SLA performance, not just monitoring the SLA metrics themselves. The professional decision-making process for similar situations should involve a framework that prioritizes proactive monitoring, trend analysis, and root cause investigation. This involves establishing robust monitoring systems, defining key performance indicators, KPI, that reflect user experience, and implementing processes for regular review and analysis of performance data. When deviations are detected, a systematic approach to root cause analysis should be employed, followed by the implementation of corrective and preventative actions. This ensures that CoS is managed holistically, leading to sustained service quality and customer satisfaction. Question 6. Analysis of the most effective and professionally responsible method for identifying potential quality of service degradations in a live Alcatel Lucent network environment, considering the imperative to maintain service continuity and adhere to regulatory service quality standards. Option A. Rely solely on customer-reported issues as the trigger for initiating any network performance investigation. Option B. Conduct extensive, real-time traffic generation tests across all network segments during peak operational hours to simulate load conditions. Option C. Temporarily disable all quality of service mechanisms to simplify the diagnostic process and isolate potential hardware faults. Option D. Implement continuous, non-intrusive monitoring of key performance indicators and traffic patterns to establish baselines and detect anomalies without impacting live traffic. The correct answer is D. Implement continuous, non-intrusive monitoring of key performance indicators and traffic patterns to establish baselines and detect anomalies without impacting live traffic. Explanation. Scenario analysis. This scenario presents a common challenge in network operations, where a service provider must balance the need for proactive network health monitoring with the potential for disruptive troubleshooting activities. The challenge lies in identifying and addressing potential quality of service, (QoS) degradations before they impact end users, without causing further service interruptions. This requires a nuanced understanding of network behavior, traffic patterns, and the impact of diagnostic tools. The professional challenge is to select a method that is both effective in identifying issues and minimally intrusive to live services, aligning with regulatory expectations for service availability and performance. Correct approach analysis. The correct approach involves utilizing non-intrusive monitoring techniques that collect performance metrics and traffic statistics without actively generating traffic that could impact existing services. This aligns with best professional practices for network management, emphasizing service continuity and minimizing operational risk. Regulatory frameworks, such as those governing telecommunications service providers, often mandate that operators maintain a certain level of service availability and performance. Non-intrusive monitoring directly supports this by allowing for early detection of anomalies and potential issues without introducing new ones. This proactive stance is crucial for meeting service level agreements, SLAs, and adhering to regulatory requirements for service quality. Incorrect approaches analysis. One incorrect approach involves performing extensive, real-time traffic generation tests across all network segments during peak hours. This is professionally unacceptable because it directly interferes with existing customer traffic, potentially causing or exacerbating QoS issues. This violates the implicit and often explicit regulatory expectation of maintaining service stability and availability. Such an approach could lead to customer complaints, SLA breaches, and potential regulatory scrutiny for service disruption. Another incorrect approach is to rely solely on reactive measures, such as waiting for customer complaints before initiating any investigation. This is a failure of professional responsibility and regulatory compliance. Regulatory bodies expect service providers to have robust monitoring and fault detection mechanisms in place to identify and resolve issues proactively. A purely reactive stance demonstrates a lack of due diligence in maintaining service quality and can lead to prolonged periods of degraded service for multiple users, increasing the likelihood of regulatory intervention. A third incorrect approach is to disable QoS mechanisms temporarily to simplify troubleshooting. While this might seem to simplify the diagnostic process, it fundamentally undermines the purpose of QoS and can lead to unpredictable traffic behavior and service degradation for users who rely on those mechanisms. This is a regulatory failure, as it deviates from the intended operational state of the network and can mask underlying QoS issues rather than resolve them. It also fails to address the root cause of potential QoS problems within the context of the deployed QoS policies. Professional reasoning. Professionals should adopt a risk-based, phased approach to network troubleshooting and QoS analysis. This involves 1. Understanding the specific QoS objectives and regulatory requirements applicable to the network and services. 2. Implementing a comprehensive suite of non-intrusive monitoring tools that capture key performance indicators, KPI and traffic statistics. 3. Establishing baseline performance metrics during normal operating conditions. 4. Developing clear escalation procedures for identified anomalies. 5. When intrusive testing is necessary, scheduling it during low traffic periods or in isolated network segments with clear rollback plans. 6. Prioritizing troubleshooting efforts based on the potential impact on service availability and customer experience, always in alignment with regulatory mandates. Question 7. Governance review demonstrates that, while network performance metrics are generally within acceptable thresholds, A recent surge in user complaints regarding intermittent application latency suggests a potential deficiency in the current quality of service (QoS) implementation. The network engineering team is tasked with evaluating the effectiveness of the existing QoS policies. Which of the following approaches best aligns with the principles of a thorough, best practice evaluation as outlined in the 4A0-107 Alcatel Lucent Quality of Service Framework? Option A. Conduct a comprehensive audit of the current QoS configuration, comparing implemented policies against established Alcatel Lucent QoS best practices for traffic classification, marking, queuing, and policing. Analyze performance data in conjunction with the configuration audit to identify specific areas where QoS mechanisms may be misconfigured or underperforming, and propose targeted adjustments based on this analysis. Option B. Immediately implement aggressive traffic shaping and rate limiting on all non-critical application traffic to free up bandwidth, assuming that current latency issues are primarily due to congestion from less important services. Option C. Rely on historical performance data and general QoS principles to make educated guesses about which QoS parameters are most likely causing the latency, and adjust them without a detailed review of the current configuration. Option D. Focus solely on increasing overall network bandwidth, as this is often the simplest solution to perceived performance problems, and assume that QoS mechanisms are functioning adequately but are simply overwhelmed by traffic volume. The correct answer is A. Conduct a comprehensive audit of the current QoS configuration, comparing implemented policies against established Alcatel Lucent QoS best practices for traffic classification, marking, queuing, and policing. Analyze performance data in conjunction with the configuration audit to identify specific areas where QoS mechanisms may be misconfigured or underperforming, and propose targeted adjustments based on this analysis. Explanation. This scenario presents a professional challenge because it requires balancing the immediate need for network performance improvements with the long-term implications of policy enforcement and the potential for unintended consequences. The core of the challenge lies in interpreting and applying the Alcatel Lucent Quality of Service (QoS) framework, specifically concerning the best practice evaluation of QoS mechanisms within the context of the 4A0-107 Exams Regulatory Framework. The exam syllabus emphasizes understanding how to evaluate and optimize QoS, not just implement it. Therefore, a superficial assessment or a reactive approach to performance issues would be professionally inadequate. The correct approach represents best professional practice because it involves a systematic, data-driven evaluation of the existing QoS configuration against established best practices as defined by the Alcatel Lucent QoS framework. This approach ensures that any proposed changes are not only effective in addressing immediate concerns, but also align with the principles of robust, scalable, and maintainable QoS design. It prioritizes understanding the root cause of performance degradation and validating the effectiveness of implemented QoS policies before making adjustments. This aligns with the ethical obligation to provide reliable and efficient network services and the professional responsibility to maintain a high standard of technical expertise. An incorrect approach that focuses solely on immediate performance metrics without understanding the underlying QoS configuration fails to adhere to the best practice evaluation principles. This could lead to suboptimal or even detrimental changes that might mask underlying issues or introduce new ones. Ethically, this represents a failure to exercise due diligence and a potential breach of professional responsibility to provide well-reasoned solutions. Another incorrect approach that relies on anecdotal evidence or assumptions about QoS effectiveness bypasses the rigorous evaluation required by best practices. This is professionally unsound as it lacks the empirical basis necessary for informed decision-making and could result in misallocation of resources or ineffective troubleshooting. It also risks violating the implicit trust placed in network professionals to make technically sound judgments. The professional decision-making process for similar situations should involve a structured approach. 1. Understand the problem. Clearly define the observed performance issue and its impact. 2. Consult the framework. Refer to the relevant sections of the Alcatel Lucent QoS framework and best practices for evaluation. 3. Gather data. Collect relevant network performance metrics and configuration details. 4. Analyze the data Evaluate the current CoS configuration against best practices, identifying discrepancies or areas for improvement. 5. Formulate solutions. Develop potential solutions based on the analysis, considering their impact on the overall CoS strategy. 6. Validate and implement. Test proposed solutions in a controlled environment before full deployment and monitor their effectiveness. 7. Document and review. Maintain thorough documentation of the process and outcomes and schedule periodic reviews. Question 8. The performance metrics show a consistent, albeit slight, increase in packet loss across several key network segments over the past week, approaching but not yet exceeding the defined SLA threshold for acceptable packet loss. The network operations team is considering several approaches to address this trend. Option A. Defer any action until the packet loss metrics definitively exceed the SLA threshold, as proactive intervention at this stage may incur unnecessary operational costs. Option B. Initiate a root cause analysis to identify the underlying factors contributing to the increasing packet loss and implement corrective actions to bring the metrics back within optimal performance ranges, even if the SLA threshold has not been breached. Option C. Focus on addressing user-reported issues that are more immediately noticeable, assuming the slight increase in packet loss is not significantly impacting end-user experience. Option D. Temporarily reconfigure network devices to artificially lower the reported packet loss metric, thereby ensuring the SLA is met while a longer-term solution is investigated. The correct answer is B. Initiate a root cause analysis to identify the underlying factors contributing to the increasing packet loss and implement corrective actions to bring the metrics back within optimal performance ranges, even if the SLA threshold has not been breached. Explanation. This scenario presents a common challenge in network operations, interpreting performance data to ensure adherence to service-level agreements, SLAs, and regulatory compliance. The professional challenge lies in distinguishing between transient network fluctuations and systemic issues that could lead to service degradation, impacting customer experience and potentially violating regulatory obligations for service availability and quality. A robust approach requires not just data observation, but also contextual understanding of network behavior and the specific requirements of the 4A0-107 Alcatel Lucent Quality of Service Framework, which emphasizes proactive management and demonstrable service delivery. The correct approach involves a systematic evaluation of the performance metrics against established baselines and SLA thresholds, coupled with an investigation into potential root causes. This aligns with best professional practice by ensuring that any identified deviations are addressed promptly and effectively, thereby maintaining service quality and fulfilling contractual and regulatory commitments. It demonstrates a commitment to operational excellence and customer satisfaction, which are implicitly or explicitly mandated by quality of service frameworks. An incorrect approach that focuses solely on immediate cost reduction without a thorough performance analysis is professionally unacceptable. This failure stems from a disregard for the potential impact on service quality and customer experience, which can lead to SLA breaches and regulatory penalties. Such an approach prioritizes short-term financial gains over long-term service integrity and compliance. Another incorrect approach that involves ignoring metrics that do not immediately trigger alarms, even if they show a negative trend, represents a failure in proactive network management. This passive stance can allow minor issues to escalate into significant problems, impacting service availability and performance. It violates the principle of continuous improvement and proactive problem-solving inherent in quality of service management. Finally, an approach that relies on anecdotal evidence or user complaints without correlating them with objective performance metrics is also professionally flawed. While user feedback is valuable, it must be substantiated by data to accurately diagnose issues and implement appropriate solutions. Relying solely on subjective reports can lead to misallocation of resources and ineffective troubleshooting, failing to address the actual root causes of performance degradation. The professional decision-making process should involve 1. Establishing clear performance baselines and SLA targets. 2. Continuous monitoring of key performance indicators, KPI. 3. Implementing automated alerting for deviations. 4. Conducting root cause analysis for any anomalies. 5. Developing and executing remediation plans. And 6. Documenting all actions and outcomes for audit and continuous improvement. This structured approach ensures that network performance is managed proactively and in compliance with all relevant standards. Question 9. Research into the effectiveness of implemented quality of service (QoS) policies within an Alcatel Lucent network, as governed by the 4A0-107 framework, requires a comprehensive evaluation. Which of the following approaches best demonstrates professional best practice in assessing the actual performance and impact of these QoS mechanisms? Option A. Relying primarily on qualitative feedback from end users regarding their perceived network experience, without correlating it with objective network performance metrics. Option B. A detailed review of all QoS configuration files and parameters to ensure they align with the theoretical specifications of the 4A0-107 framework. Option C. Analyzing real-time and historical network performance data, including metrics such as latency, jitter, and packet loss, and correlating these with user-reported service quality issues and defined service-level agreements. Option D. Conducting a series of controlled experiments simulating ideal network conditions to measure the theoretical maximum performance of the QoS features. The correct answer is B. A detailed review of all QoS configuration files and parameters to ensure they align with the theoretical specifications of the 4A0-107 framework. Explanation. This scenario presents a professional challenge in evaluating the effectiveness of quality of service (QoS) mechanisms within a telecommunications network, specifically concerning the Alcatel Lucent 4A0-107 framework. The challenge lies in moving beyond theoretical understanding to practical, evidence-based assessment of how implemented QoS policies are actually performing against defined objectives and regulatory expectations. A key aspect is the need to demonstrate tangible improvements or identify specific shortcomings that impact user experience and service delivery, aligning with the spirit of regulatory oversight that prioritizes reliable and predictable service. The correct approach represents best professional practice because it involves a systematic, data-driven evaluation of QoS performance against established benchmarks and user impact. This aligns with the principles of continuous improvement and accountability inherent in QoS management. By analyzing actual traffic flows, performance metrics like latency, jitter, packet loss, and correlating these with user-perceived quality, professionals can validate the efficacy of QoS configurations. This proactive and analytical stance is crucial for ensuring compliance with service-level agreements, SLAs, and any applicable regulatory mandates that might specify performance thresholds for critical services. It demonstrates a commitment to operational excellence and customer satisfaction, which are often implicit or explicit goals of QoS frameworks. An incorrect approach that focuses solely on configuration review without performance validation fails to address the practical reality of network operation. While configurations might appear correct on paper, real-world network conditions, traffic patterns, and equipment behavior can lead to deviations. This approach risks overlooking actual performance degradation, potentially leading to SLA breaches and customer dissatisfaction, which could attract regulatory scrutiny. Another incorrect approach that relies on anecdotal user feedback without objective data is also professionally unsound. While user feedback is valuable, it is subjective and can be influenced by various factors unrelated to QoS. Without objective performance metrics, it is impossible to definitively diagnose the root cause of perceived issues or to measure the impact of QoS interventions accurately. This can lead to misallocation of resources and ineffective troubleshooting, failing to meet the rigorous standards expected in QoS management. A third incorrect approach that prioritizes theoretical QoS model adherence over observed performance is problematic. While understanding QoS models is foundational, the ultimate goal is to achieve desired performance outcomes in a live network. Focusing exclusively on theoretical compliance without verifying actual results means the implemented QoS might not be achieving its intended purpose, even if it adheres to the model's structure. This can lead to a disconnect between design and operation, undermining the effectiveness of the QoS strategy. The professional reasoning process for similar situations should involve a structured approach. 1. Define clear objectives. Understand the specific QoS goals and the expected outcomes for different service types. 2. Data collection. Gather comprehensive performance data from network monitoring tools, including metrics relevant to latency, jitter, packet loss, and throughput. 3. Correlation and analysis. Correlate performance data with traffic patterns and user experience indicators. 4. Benchmarking. Compare observed performance against defined SLAs, industry best practices, and regulatory requirements. 5. Root cause analysis. If performance deviates from objectives, systematically identify the underlying causes, which may involve co-S configurations, network congestion, or equipment issues. 6. Remediation and validation. Implement corrective actions and then reevaluate performance to confirm the effectiveness of the changes. 7. Reporting and documentation. Maintain detailed records of findings, actions taken, and outcomes to demonstrate due diligence and support continuous improvement. Question 10. The risk matrix shows a moderate probability of service degradation impacting a critical customer segment due to intermittent packet loss on a core network segment. The immediate business pressure is to restore full service to this customer as quickly as possible. Considering the Alcatel Lucent 4A0-107 quality of service framework, which of the following actions best represents a professional and compliant approach to addressing this situation? Option A. Immediately roll back the most recent network configuration change on the affected segment, assuming it is the most likely cause, and monitor for service improvement. Option B. Increase the priority of all traffic traversing the affected segment to mitigate the perceived impact of packet loss without investigating the root cause. Option C. Inform the customer that intermittent packet loss is a known issue and that the network team is working on a general optimization without providing specific details or timelines. Option D. Initiate a deep packet inspection on the affected segment to identify the specific traffic patterns contributing to packet loss. Correlate this with recent network configuration changes and analyze the impact on defined co-S metrics before proposing a targeted resolution. The correct answer is D. Initiate a deep packet inspection on the affected segment to identify the specific traffic patterns contributing to packet loss. Correlate this with recent network configuration changes and analyze the impact on defined co-S metrics before proposing a targeted resolution. Explanation. This scenario presents a professional challenge because it requires balancing the immediate need for service restoration with the long-term implications of network stability and adherence to quality of service, co-S policies. The risk matrix highlights potential impacts, but the decision maker must interpret these risks within the context of the Alcatel Lucent 4A0-107 quality of service framework, which emphasizes proactive management and adherence to defined service level agreements, SLAs. The correct approach represents best professional practice because it prioritizes a systematic, data-driven investigation aligned with co-S principles by analyzing the root cause of the degradation and its impact on defined co-S parameters, e.g., latency, jitter, packet loss. As stipulated by the 4A0-107 syllabus, the engineer ensures that any remediation is targeted and effective. This approach also involves assessing the impact on SLAs, a core tenet of co-S management, and documenting findings for future reference and continuous improvement. This aligns with the regulatory expectation of maintaining service quality and demonstrating due diligence. An incorrect approach that bypasses root cause analysis and immediately implements a broad configuration change without understanding the underlying issue is professionally unacceptable. This could lead to unintended consequences, further service degradation, or the masking of a more critical underlying problem. Such an action fails to adhere to the systematic troubleshooting and analysis expected under co-S frameworks and could violate contractual obligations if SLAs are breached due to poorly understood interventions. Another incorrect approach, focusing solely on restoring the affected service without considering the broader network impact or the potential for recurrence, demonstrates a lack of comprehensive co-S management. This reactive approach neglects the proactive elements of co-S, such as identifying trends, potential vulnerabilities, and ensuring the overall health of the network. It fails to leverage the diagnostic tools and methodologies emphasized in co-S training, potentially leading to repeated incidents and a decline in overall service quality. A professional decision-making process for similar situations involves 1. Understanding the reported issue and its potential impact. 2. Consulting the risk matrix and relevant co-S documentation, e.g., SLAs, network policies. 3. Initiating a structured troubleshooting process, prioritizing root cause analysis. 4. utilizing diagnostic tools and methodologies to gather data on CoS parameters. 5. Evaluating potential solutions based on their effectiveness, impact, and adherence to CoS principles. 6. Implementing the chosen solution with careful monitoring. 7. Documenting the entire process, findings, and resolution for future reference and continuous improvement. Question 11. Cost-benefit analysis shows that implementing advanced quality of service, CoS mechanisms on the enterprise network could significantly improve application performance for critical business functions. However, the network infrastructure is complex, and the operational team has limited bandwidth for new initiatives. Considering the need for a stable and reliable network, which approach best balances the potential benefits of CoS with operational realities and regulatory expectations for service delivery. Option A. Implement CoS features incrementally, starting with the most impactful and least complex mechanisms, followed by rigorous testing and monitoring before proceeding to more advanced features. Option B. Defer CoS implementation until the operational team has more capacity, prioritizing immediate network stability over potential future performance improvements. Option C. Focus on implementing the most technically sophisticated CoS features, as these are likely to offer the greatest long-term performance gains, regardless of immediate operational challenges. Option D. Immediately deploy all identified CoS features across the entire network to realize the full potential benefits as quickly as possible, assuming the operational team can adapt. The correct answer is A. Implement CoS features incrementally, starting with the most impactful and least complex mechanisms, followed by rigorous testing and monitoring before proceeding to more advanced features. Explanation. This scenario presents a common challenge in network management, balancing the desire for enhanced quality of service, CoS, with the practical constraints of resource allocation and operational complexity. The professional challenge lies in making an informed decision that aligns with both technical feasibility and the overarching business objectives, while adhering to the principles of efficient network operation as implicitly guided by the Alcatel Lucent 4A0-107 framework, which emphasizes practical, implementable CoS solutions. The correct approach, focusing on a phased implementation of CoS mechanisms, represents best professional practice because it allows for controlled deployment, thorough testing, and iterative refinement. This aligns with a pragmatic approach to network engineering, where changes are introduced incrementally to minimize disruption and risk. It allows for validation of the cost-benefit analysis in a real-world environment, ensuring that the perceived benefits of improved CoS are actually realized without incurring disproportionate operational overhead or negatively impacting other network functions. This methodical approach is crucial for maintaining network stability and ensuring that investments in CoS yield tangible returns. An incorrect approach that prioritizes immediate widespread deployment of all potential CoS features without adequate planning or testing would be professionally unacceptable. This would represent a failure to adhere to sound engineering principles, potentially leading to network instability, performance degradation, and wasted resources. Such an approach could also violate implicit regulatory or ethical considerations related to providing a reliable service. A poorly implemented CoS strategy could inadvertently degrade service for some users while attempting to improve it for others, leading to customer dissatisfaction and potential breaches of service-level agreements. Another incorrect approach, focusing solely on the most technically sophisticated CoS features without considering their operational impact or the actual business need, would also be professionally unsound. This demonstrates a lack of strategic thinking and a failure to align technical solutions with business objectives. It could lead to the implementation of complex, resource-intensive features that provide marginal or no real benefit to end users or the business, thus failing the core purpose of a cost-benefit analysis. The professional decision-making process for similar situations should involve a thorough understanding of the network's current state, a clear definition of the desired CoS outcomes, and a realistic assessment of available resources and operational capabilities. This includes engaging with stakeholders to understand business priorities, conducting detailed technical assessments of potential CoS solutions, and developing a phased implementation plan that includes monitoring and feedback loops. The decision should be driven by a clear demonstration of value, balancing technical merit with operational feasibility and business impact, always prioritizing stability and reliability. Question 12. Which approach would be most effective in implementing quality of service (QoS) policies on a large enterprise network to ensure optimal performance for critical applications while minimizing operational risk and unintended service degradation? Option A. Configure QoS policies with strict rate limiting and potential packet dropping for any traffic not explicitly classified as critical, assuming non-critical traffic can tolerate some loss. Option B. Implement QoS policies based on theoretical network load predictions without performing actual traffic monitoring and defer monitoring and validation until after the full deployment. Option C. Immediately deploy a network-wide QoS policy with aggressive bandwidth shaping and prioritization for all identified critical applications based on vendor best practices. Option D. Conduct a comprehensive traffic analysis to identify critical application flows and their performance requirements, followed by a phased pilot implementation of QoS policies on a subset of the network, with continuous monitoring and iterative refinement. Correct answer is D. Conduct a comprehensive traffic analysis to identify critical application flows and their performance requirements, followed by a phased pilot implementation of QoS policies on a subset of the network, with continuous monitoring and iterative refinement. Explanation. This scenario presents a common implementation challenge in quality of service (QoS) management, balancing the need for granular traffic control with the operational complexity and potential for unintended consequences. The challenge lies in accurately identifying and classifying traffic that requires specific QoS treatment without negatively impacting other critical services or introducing configuration errors that could lead to service degradation. Professionals must navigate the technical intricacies of QoS mechanisms while adhering to service-level agreements, SLAs, and ensuring network stability. The correct approach involves a phased, data-driven methodology that prioritizes understanding existing traffic patterns and their impact before implementing broad QoS policies. This typically begins with comprehensive traffic monitoring and analysis to establish baseline performance metrics and identify traffic types that are most sensitive to latency or jitter. Subsequently, a pilot implementation of QoS policies on a limited segment of the network allows for validation of configuration effectiveness and identification of any adverse effects on other traffic flows. This iterative process, informed by real-world data, minimizes risk and ensures that QoS policies are both effective and sustainable, aligning with the principles of responsible network management and the implicit requirement to maintain service availability as per industry best practices and any governing SLAs. An incorrect approach would be to implement a comprehensive, network-wide QoS policy based solely on theoretical assumptions or vendor recommendations without prior traffic analysis. This bypasses the critical step of understanding the actual traffic mix and its performance characteristics, leading to a high probability of misclassification, inefficient resource allocation, and potential service disruption for legitimate traffic. Such an approach fails to uphold the professional responsibility to ensure network stability and service integrity, potentially violating implicit or explicit contractual obligations related to service availability and performance. Another incorrect approach is to configure QoS policies with overly aggressive drop or policing actions for perceived non-critical traffic without a clear understanding of its actual business impact or dependencies. This can lead to the degradation or outright loss of important, albeit less bandwidth-intensive, traffic, causing business disruption and reputational damage. This demonstrates a lack of due diligence and a failure to consider the broader implications of QoS decisions beyond immediate technical metrics, which is professionally unsound. Finally, implementing QoS policies without a robust monitoring and alerting system in place is also a flawed strategy. While the configuration might be technically sound, the absence of mechanisms to detect and respond to deviations from expected performance or unintended consequences means that issues may go unnoticed until they escalate into significant service outages. This reactive rather than proactive stance is a failure in professional responsibility for ongoing network health and performance management. The professional decision-making process should involve a systematic approach. First, define clear QoS objectives aligned with business requirements and SLAs. Second, conduct thorough traffic analysis to understand current patterns and sensitivities. Third, design and pilot QoS policies in a controlled environment. Fourth, implement and continuously monitor the effectiveness of the policies, making adjustments as needed. And fifth, maintain comprehensive documentation of all configurations and their rationale. Question 13. The review process indicates that a specific application experiencing intermittent packet loss and increased latency is being managed by multiple, potentially overlapping quality of service (QoS) policies within the Alcatel Lucent network. The network engineer is tasked with resolving this issue while ensuring compliance with the established QoS framework. Which of the following actions represents the most professional and effective approach to diagnose and resolve the problem? Option A. Systematically analyze the interaction between all QoS policies affecting the application's traffic, correlating observed performance degradation with specific policy configurations and traffic shaping parameters. Option B. Immediately disable all QoS policies related to the affected application to isolate whether QoS is the root cause of the performance degradation. Option C. Focus solely on increasing the bandwidth allocated to the affected application, assuming that congestion is the primary driver of the issues. Option D. Randomly adjust queue depths and scheduling algorithms for the affected traffic class, hoping to stumble upon a configuration that improves performance. The correct answer is A. Systematically analyze the interaction between all QoS policies affecting the application's traffic, correlating observed performance degradation with specific policy configurations and traffic shaping parameters. Explanation. This scenario presents a professional challenge because it requires balancing the technical implementation of quality of service (QoS) mechanisms with the potential for unintended consequences that could impact network stability and user experience. The challenge lies in accurately diagnosing the root cause of perceived performance degradation when multiple QoS policies are in play, and ensuring that any adjustments made are compliant with the established service level agreements, SLAs, and the Alcatel Lucent Quality of Service framework. Careful judgment is required to avoid overcorrection or misapplication of QoS policies, which could exacerbate the problem or violate contractual obligations. The correct approach represents best professional practice because it prioritizes a systematic, data-driven investigation before implementing changes. This aligns with the principles of responsible network management and adherence to the Alcatel Lucent Quality of Service framework, which emphasizes understanding the existing configuration and its impact. By analyzing traffic patterns, policy interactions, and potential bottlenecks, the engineer can identify the precise cause of the issue. This methodical approach ensures that any modifications are targeted, effective, and do not introduce new problems, thereby upholding the integrity of the QoS implementation and meeting the defined service levels. An incorrect approach that involves immediately disabling or significantly altering QoS policies without a thorough understanding of their purpose and interaction is professionally unacceptable. This could lead to a complete breakdown of traffic prioritization, resulting in widespread performance degradation for all services, not just the one experiencing issues. This violates the fundamental principles of QoS and the intent of the Alcatel Lucent framework, which is to manage and guarantee service quality. Furthermore, such an action could constitute a breach of SLA commitments, leading to contractual penalties and reputational damage. Another incorrect approach, such as randomly adjusting queue depths or scheduling algorithms without correlating them to the observed traffic behavior, demonstrates a lack of analytical rigor. This is akin to treating symptoms without diagnosing the disease. It is unlikely to resolve the underlying issue and may even worsen network performance by misallocating resources or creating new congestion points. This approach fails to demonstrate due diligence and a commitment to understanding the complex interplay of QoS parameters. The professional decision-making process for similar situations should involve a structured troubleshooting methodology. This begins with clearly defining the problem and its scope. Next, gather all relevant data, including network statistics, QoS configurations, and user reports. Analyze this data to form hypotheses about the root cause. Test these hypotheses systematically, ideally in a controlled environment or with minimal impact on production traffic. Implement changes incrementally, monitoring their effect closely. Document all findings, actions, and outcomes. This iterative process ensures that solutions are robust, compliant, and effective, reflecting a deep understanding of the Alcatel Lucent Quality of Service principles. Question 14. The analysis reveals that a newly deployed Alcatel Lucent enterprise service is experiencing unacceptable levels of jitter, impacting the customer's real-time applications. The Service Level Agreement, SLA, specifies a maximum jitter tolerance. Given the complexity of the network, which of the following diagnostic and resolution approaches best adheres to professional best practices for ensuring CO-S compliance and customer satisfaction? Option A. Focus solely on troubleshooting the customer's internal network infrastructure, assuming the service provider's network is functioning optimally as per standard operating procedures. Option B. Implement a broad set of CO-S parameter adjustments across the entire network segment serving the customer, based on common jitter mitigation techniques, without specific root cause analysis. Option C. Immediately escalate the issue to the Alcatel Lucent vendor support team, requesting a full network audit without performing any initial on-site or in-house diagnostics. Option D. Initiate a deep dive into the Alcatel Lucent core network CO-S configurations, specifically examining traffic shaping and queuing policies, after first verifying the customer's edge device configuration and the immediate network ingress points for any anomalies. The correct answer is D. Initiate a deep dive into the Alcatel Lucent core network CO-S configurations, specifically examining traffic shaping and queuing policies, after first verifying the customer's edge device configuration and the immediate network ingress points for any anomalies. Explanation. Scenario analysis. This scenario presents a professional challenge in network deployment where a critical quality of service, CO-S parameter, specifically jitter, is not meeting the agreed-upon service level agreement, SLA, for a new enterprise customer. The challenge lies in diagnosing the root cause of the jitter within a complex Alcatel Lucent network infrastructure without disrupting existing services or further degrading the customer's experience. The pressure to resolve this quickly is high due to the customer's reliance on consistent performance for their business operations and the potential for financial penalties if the SLA is breached. Accurate identification of the source of jitter is paramount to implementing an effective and timely solution. Correct approach analysis. The correct approach involves a systematic, layered investigation that begins with verifying the customer's reported issue and then progressively examines the network path for potential causes of jitter. This starts with checking the customer's edge equipment and their immediate connection to the service provider's network. If no issues are found there, the investigation moves deeper into the provider's core network, examining traffic shaping, queuing mechanisms, and any intermediate devices that might be introducing variable delays. This methodical approach aligns with best professional practices by ensuring that the simplest and most probable causes are ruled out first, minimizing unnecessary complexity and potential for further disruption. It also adheres to the spirit of CO-S delivery by prioritizing the customer's experience and the contractual obligations outlined in the SLA. The focus on identifying the specific Alcatel Lucent CO-S features or configurations that might be contributing to jitter, such as misconfigured traffic policing, inadequate buffer management, or suboptimal queuing strategies, is crucial. Incorrect approaches analysis. One incorrect approach is to immediately assume a core network issue and begin making broad configuration changes without a thorough initial assessment. This is professionally unsound as it risks introducing new problems or exacerbating existing ones without a clear understanding of the root cause. It bypasses the fundamental troubleshooting principle of starting with the most likely and simplest explanations. This approach could lead to a violation of service delivery standards by causing further degradation or outages, and potentially breaching contractual obligations if the changes are not properly documented or validated. Another incorrect approach is to focus solely on the customer's internal network without adequately verifying the service provider's network path. While customer-side issues can contribute to perceived jitter, a responsible service provider must first confirm that their own infrastructure is performing as expected according to the SLA. Neglecting to thoroughly examine the provider's network, including Alcatel Lucent-specific CO-S implementations, represents a failure to uphold contractual responsibilities and a lack of due diligence in service assurance. This can lead to customer dissatisfaction and disputes over service quality. A third incorrect approach is to rely on anecdotal evidence or past experiences with similar issues without performing specific diagnostics for the current deployment. Each network environment and customer configuration is unique. Making assumptions based on past events without validating them in the current context can lead to misdiagnosis and wasted effort. This demonstrates a lack of rigorous problem solving and can result in prolonged service degradation, impacting the customer's business and the provider's reputation. Professional reasoning. Professionals should adopt a structured troubleshooting methodology. This involves 1. Clearly defining the problem and its impact. 2. Gathering all relevant information, including customer reports, network topology, and current configurations. 3. Formulating hypotheses about potential causes. 4. Testing these hypotheses systematically, starting with the most probable and least disruptive. 5. Implementing solutions based on confirmed diagnoses. 6. Verifying the resolution and documenting the process. In CO-S-related issues, a deep understanding of the specific Alcatel Lucent CO-S mechanisms in play, e.g., traffic shaping, policing, queuing algorithms, priority queuing, is essential for accurate diagnosis and effective remediation. This systematic and evidence-based approach ensures that solutions are targeted, efficient, and minimize risk to service availability and quality. Question 15. System analysis indicates that a newly deployed quality of service (QoS) policy on a critical network segment is not yielding the expected performance improvements for high-priority voice traffic, despite the configuration appearing correct on individual network devices. The policy includes traffic classification, marking, policing, and egress queuing. What is the most effective approach to diagnose and resolve this implementation challenge? Option A. Rely on the default QoS settings for voice traffic, assuming they are optimized for most network scenarios and that manual configuration is often unnecessary. Option B. Focus solely on reviewing the ingress policing configuration on the edge devices, as this is the primary mechanism for controlling traffic rates entering the network. Option C. Conduct end-to-end traffic flow analysis, verifying classification, marking, policing, and egress queuing behavior across all relevant network devices, and links to identify discrepancies between the intended policy and actual traffic treatment. Option D. Assume the issue lies with the voice application itself and recommend application-level tuning, as network QoS configurations are generally robust once applied. The correct answer is C. Conduct end-to-end traffic flow analysis, verifying classification, marking, policing, and egress queuing behavior across all relevant network devices, and links to identify discrepancies between the intended policy and actual traffic treatment. Explanation. Scenario analysis. This scenario presents a common implementation challenge in quality of service (QoS) management. The discrepancy between theoretical QoS policy design and its practical application within a complex network environment. The challenge lies in ensuring that the intended QoS behavior, designed to meet specific service level agreements, SLAs, and regulatory requirements, as per the 4A0-107 Alcatel Lucent Quality of Service Framework, which implicitly governs adherence to service delivery standards, is accurately reflected in the operational network. Misinterpreting or misapplying QoS mechanisms can lead to service degradation, customer dissatisfaction, and potential breaches of contractual obligations, all of which have significant business and reputational consequences. The difficulty is amplified by the need to understand the intricate interplay of various QoS features and their impact on different traffic classes. Correct approach analysis. The correct approach involves a thorough, end-to-end verification of the QoS configuration against the defined policy and expected outcomes. This means not just checking individual device configurations, but also validating the behavior of traffic flows across multiple network segments. It requires understanding how queuing, policing, shaping, and marking mechanisms interact, and how they are applied to specific traffic classes. This approach aligns with best professional practices by ensuring that the implemented QoS solution is functional, effective, and compliant with the underlying service requirements. It directly addresses the core objective of QoS implementation, to guarantee a certain level of performance for critical services, thereby upholding the integrity of service delivery and customer trust. This proactive validation minimizes the risk of service disruptions and ensures that the network operates as intended, meeting the performance metrics stipulated in SLAs and any relevant industry guidelines that the 4A0-107 framework would support. Incorrect approaches analysis. One incorrect approach is to solely rely on the configuration files of individual network devices without verifying the actual traffic behavior. This fails to account for potential misconfigurations, unexpected interactions between devices, or environmental factors that might alter traffic flow. Ethically and professionally, this is a failure to perform due diligence, as it assumes correctness without empirical validation, can lead to a false sense of security, where the network appears configured correctly, but is not delivering the promised CoS, potentially violating service commitments. Another incorrect approach is to assume that the default CoS settings will suffice for all traffic types. This is a significant professional oversight, because CoS is inherently about differentiating traffic and applying specific treatments based on business needs and service priorities. Relying on defaults ignores the fundamental purpose of CoS and is likely to result in suboptimal performance for critical applications, leading to service degradation and customer complaints. This approach demonstrates a lack of understanding of CoS principles and a failure to meet the requirements of a well-designed CoS policy. A third incorrect approach is to focus only on the ingress policing of traffic, neglecting the egress queuing and scheduling mechanisms. While ingress policing controls the rate of traffic entering the network, egress mechanisms are crucial for managing how traffic is prioritized and transmitted out of an interface, especially during congestion. Ignoring egress behavior means that even if traffic is policed correctly at the entry point, it might still experience unacceptable delays or packet loss when leaving a congested link, thus failing to meet CoS objectives. This represents a partial and incomplete understanding of CoS implementation, leading to an ineffective solution. Professional reasoning. Professionals faced with this scenario should adopt a systematic and verification-centric approach. The decision-making process should begin with a clear understanding of the CoS policy and its objectives, followed by a detailed review of the intended configuration. Crucially, this must be complemented by rigorous testing and validation of actual traffic behavior across the network. This involves using network monitoring tools, traffic generators, and packet analysis to confirm that traffic is being classified, marked, policed, shaped, and queued as per the design. When discrepancies arise, the professional must be able to diagnose the root cause, which could stem from configuration errors, hardware limitations, or a misunderstanding of traffic patterns. The ultimate goal is to ensure that the implemented CoS solution reliably delivers the agreed-upon service levels, thereby maintaining customer satisfaction and adhering to professional and contractual obligations. Question 16. The control framework reveals that a specific traffic class is experiencing intermittent packet loss and increased latency, impacting user experience. To address this immediate issue, which of the following actions best aligns with the principles of effective quality of service management as defined by the 4A0-107 Alcatel Lucent Quality of Service Framework? Option A. Temporarily disable CoS policing for the affected traffic class to allow all traffic to pass without restriction. Option B. Manually adjust the queue parameters for the affected traffic class without consulting the overall CoS policy. Option C. Analyze the CoS policy configuration and traffic shaping parameters for the affected class to identify any discrepancies or potential misconfigurations that might explain the observed performance degradation. Option D. Immediately increase the bandwidth allocation for the affected traffic class to alleviate congestion and restore performance. The correct answer is C. Analyze the CoS policy configuration and traffic shaping parameters for the affected class to identify any discrepancies or potential misconfigurations that might explain the observed performance degradation. Explanation. Scenario analysis. This scenario presents a professional challenge due to the inherent conflict between immediate network performance demands and the long-term implications of CoS policy enforcement. The pressure to restore service quickly can lead to hasty decisions that might bypass established CoS control mechanisms. The challenge lies in balancing the urgency of the situation with the need for adherence to the defined CoS framework, ensuring that temporary fixes do not compromise the integrity or effectiveness of the overall CoS strategy. This requires a deep understanding of the CoS principles and their practical application within the Alcatel Lucent framework, as well as the ability to assess the potential downstream impacts of any intervention. Correct approach analysis. The correct approach involves a thorough analysis of the observed traffic patterns against the established CoS policies and traffic profiles. This aligns with the principles of effective co-S management, which mandate that deviations from expected performance should be investigated through the lens of the defined control framework. By examining the co-S policy configuration and the traffic shaping parameters, the network administrator can identify whether the observed behavior is a result of misconfiguration, an unexpected traffic surge that exceeds policy limits, or a genuine anomaly requiring adjustment. This methodical approach ensures that any corrective actions are informed, targeted, and compliant with the regulatory and operational guidelines governing co-S implementation, thereby maintaining the integrity of the service level agreements and the network's overall performance. Incorrect approach is analysis. Implementing a blanket increase in bandwidth allocation without understanding the root cause of the performance degradation is a regulatory and ethical failure. It bypasses the fundamental principle of co-S, which is to manage resources intelligently based on defined policies and traffic characteristics. This approach can lead to inefficient resource utilization, potentially impacting other services and violating the fairness principles embedded in co-S frameworks. It also fails to address the underlying issue, which could be a misconfiguration or a specific traffic type causing congestion, meaning the problem is likely to recur. Disabling co-S policing for the affected traffic class, even temporarily, represents a significant regulatory and ethical lapse. Co-S policing is a critical mechanism for enforcing service-level agreements and preventing network abuse. Disabling it undermines the entire co-S framework, potentially allowing rogue or excessive traffic to consume resources, thereby degrading service for legitimate users and violating the commitments made to customers. This action directly contravenes the purpose of implementing a robust co-S control framework. Manually adjusting individual queue parameters without reference to the overall co-S policy and traffic profiles is also professionally unsound. Co-S is a system-level concern, and ad hoc adjustments to individual components can have unintended consequences on other parts of the network and other traffic classes. This approach lacks the systematic rigor required for effective co-S management and can lead to unpredictable network behavior, making it difficult to troubleshoot future issues and potentially violating the spirit of the defined co-S architecture. Professional reasoning. Professionals facing such a scenario should first consult the established co-S documentation and the 4A0-107 Alcatel Lucent Quality of Service Framework. The decision-making process should involve 1. Identifying the specific symptoms of the performance degradation. 2. Correlating these symptoms with the defined co-S policies and traffic profiles. 3. Utilizing diagnostic tools to analyze traffic behavior against these policies. 4. Determining if the observed behavior is within the expected parameters of the co-S policy or indicates a deviation. 5. If a deviation is identified, assessing whether it's due to misconfiguration, an anomaly, or a need for policy adjustment. 6. Implementing corrective actions that are consistent with the co-S framework and documented thoroughly. This systematic approach ensures that interventions are data-driven, compliant, and contribute to the overall stability and performance of the network. Question 17. During the evaluation of a new enterprise customer service, it is observed that the delivered voice traffic is experiencing unacceptable levels of jitter, impacting call quality and failing to meet the agreed-upon service level agreement (SLA) on an Alcatel Lucent network. The customer service path traverses several Alcatel Lucent routers and switches. What is the most effective initial approach to diagnose and resolve this jitter issue? Option A. Increase the bandwidth allocated to the voice traffic class across all network segments without first identifying the specific cause of the delay variation. Option B. Immediately reconfigure the core network routing protocols to prioritize voice traffic, assuming the issue stems from general network congestion in the backbone. Option C. Systematically verify the customer's edge equipment and the immediate network interface for any local congestion or misconfiguration. Then proceed to examine the Alcatel Lucent network elements along the service path, focusing on co-S configurations such as queuing, policing, and shaping. Option D. Implement a network-wide co-S policy overhaul, applying aggressive jitter buffering techniques on all devices to mitigate the observed problem. The correct answer is C. Systematically verify the customer's edge equipment and the immediate network interface for any local congestion or misconfiguration. Then proceed to examine the Alcatel Lucent network elements along the service path, focusing on co-S configurations such as queuing, policing, and shaping. Explanation. Scenario analysis. This scenario presents a professional challenge in network deployment where a critical quality of service, CoS, parameter, specifically jitter, is not meeting the defined service level agreement, SLA, for a new enterprise customer. The challenge lies in accurately diagnosing the root cause of the jitter within a complex Alcatel Lucent network environment, which involves multiple potential points of failure or misconfiguration. The pressure to resolve this quickly is high due to the customer's reliance on consistent performance for their business operations, directly impacting the service provider's reputation and potential revenue. Careful judgment is required to avoid making hasty decisions that could exacerbate the problem or lead to unnecessary infrastructure changes. Correct approach analysis. The correct approach involves a systematic, layered investigation of the network path, starting from the customer edge and moving towards the core. This method aligns with best practices for network troubleshooting and adheres to the principles of CoS management as outlined in industry standards and vendor best practices, which are implicitly expected within the context of the 4A0-107 exam. Specifically, it prioritizes verifying the customer's equipment and the immediate network interface for any local congestion or misconfiguration that could introduce jitter. Subsequently, it examines the Alcatel Lucent network elements along the service path, focusing on CoS configurations such as queuing mechanisms, policing, and shaping, which are directly responsible for managing traffic flow and mitigating jitter. This methodical approach ensures that the simplest and most probable causes are ruled out first, preventing over-engineering or misdiagnosis. The focus on specific Alcatel Lucent CoS features, e.g., weighted fair queuing, strict priority queuing, traffic shaping profiles, is crucial for effective resolution within the specified vendor framework. Incorrect approaches analysis. One incorrect approach would be to immediately assume a core network issue and begin reconfiguring high-level routing protocols or complex traffic engineering policies without first verifying the customer's local environment and the immediate access links. It bypasses fundamental troubleshooting steps and risks introducing new problems or misattributing the cause. It fails to adhere to the principle of isolating the fault domain efficiently. Another incorrect approach would be to solely focus on increasing bandwidth allocation for the affected traffic without understanding the underlying cause of the jitter. Jitter is often a symptom of packet delay variation, not necessarily insufficient bandwidth. Simply increasing bandwidth might mask the problem temporarily or be ineffective if the root cause is queue management or packet drops due to misconfigured CoS policies. This approach neglects the specific mechanisms designed to control delay variation. A third incorrect approach would be to make broad, sweeping changes to CoS policies across the entire network without a clear hypothesis or targeted testing. This is a shotgun approach that is highly disruptive, difficult to reverse, and unlikely to pinpoint the specific cause of the customer's jitter issue. It demonstrates a lack of systematic problem solving and a disregard for the potential impact on other services. Professional reasoning. Professionals should adopt a structured troubleshooting methodology, often referred to as the bottom-up or layered approach. This involves starting at the physical layer and progressing upwards, or in this case, starting at the customer edge and moving inwards. For CoS issues, this means 1. Verify customer premises equipment and local connectivity. 2. Examine the access network interface and policing/shaping configurations. 3. Trace the service path through the Alcatel Lucent network, inspecting CoS configurations, queuing, scheduling, marking on each hop. 4. Utilize network monitoring tools to gather real-time performance data and identify anomalies. 5. Formulate a hypothesis based on collected data and test it systematically. 6. Implement targeted changes and verify resolution. This process ensures that resources are used efficiently, the impact of changes is minimized, and the root cause is accurately identified and addressed, thereby upholding the service provider's commitment to the SLA. Question 18. Strategic planning requires a careful evaluation of network infrastructure components to ensure optimal performance and adherence to service-level objectives. When considering a new quality of service, CoS, solution, what approach best balances immediate deployment needs with long-term organizational goals of flexibility and cost efficiency, while adhering to principles of open standards and interoperability? Option A. Select a CoS solution based solely on the perceived ease of integration, without a comprehensive assessment of long-term implications and vendor lock-in risks. Option B. Prioritize a standards-based, multi-vendor co-S solution that allows for interoperability and competitive sourcing. Option C. Implement a co-S solution that relies heavily on manual configuration and lacks automated policy enforcement for initial cost savings. Option D. Immediately adopt the vendor's proprietary co-S solution, as it offers seamless integration and faster deployment. The correct answer is B. Prioritize a standards-based, multi-vendor co-S solution that allows for interoperability and competitive sourcing. Explanation. Scenario analysis. This scenario presents a common implementation challenge in quality of service, co-S, deployment. The conflict between a vendor's proprietary solution and the organization's strategic goal of interoperability and avoiding vendor lock-in. The challenge lies in balancing the immediate perceived benefits of a quick, integrated solution with the long-term risks of technical and commercial dependence. A professional must assess not only the technical merits, but also the strategic implications, cost-effectiveness, and adherence to organizational policies and industry best practices for co-S management. Correct approach analysis. The correct approach prioritizes a standards-based, multi-vendor co-S solution. This aligns with best professional practice by ensuring interoperability, fostering competition among vendors, and providing flexibility for future network evolution. From a regulatory and ethical standpoint, this approach promotes transparency and avoids creating an unfair advantage for a single vendor, which could indirectly impact service delivery and cost to end users if not managed carefully. It also supports the organization's long-term strategic objectives of maintaining control over its network infrastructure and avoiding costly vendor lock-in, which is a prudent financial and operational consideration. Incorrect approaches analysis. Adopting the vendor's proprietary co-S solution without thorough evaluation or consideration of alternatives represents a significant regulatory and ethical failure. It risks creating a vendor lock-in situation, which can lead to inflated costs, limited innovation, and difficulties in integrating future technologies. This approach may also violate internal procurement policies that mandate competitive bidding and the evaluation of open standards. Ethically, it could be seen as a failure to act in the best interest of the organization by not exploring all viable and potentially more cost-effective or flexible options. Implementing a co-S solution that relies heavily on manual configuration and lacks automated policy enforcement mechanisms is also professionally unacceptable. While it might seem like a short-term cost-saving measure, it significantly increases the risk of human error, inconsistent co-S application, and difficulties in scaling and maintaining the co-S framework. This can lead to service degradation and non-compliance with service-level agreements, SLAs, which has direct regulatory implications if SLAs are contractual obligations. It demonstrates a lack of foresight and a failure to implement robust, scalable, and reliable co-S management. Focusing solely on the perceived ease of integration of the proprietary solution without a comprehensive assessment of its long-term implications, including support, upgrades, and potential future interoperability issues, is a flawed decision-making process. This approach neglects the critical due diligence required for significant technology investments. It can lead to unforeseen costs and operational complexities down the line, potentially impacting the organization's ability to meet its co-S commitments and adhere to any relevant service delivery regulations. Professional reasoning. Professionals should approach such decisions by first understanding the organization's strategic goals for co-S, including desired levels of service, scalability, and future-proofing. A thorough market analysis of available co-S solutions, prioritizing those based on open standards and industry best practices, is essential. This should be followed by a detailed technical and commercial evaluation of shortlisted solutions, including proof-of-concept deployments where feasible. Risk assessment, focusing on vendor lock-in, long-term costs, and interoperability, must be a core component of the evaluation. Finally, decisions should be documented, with clear justifications based on technical merit, cost-effectiveness, strategic alignment, and adherence to organizational policies and relevant regulatory guidelines. Question 19. The performance metrics show a consistent and significant deviation from the agreed-upon quality of service, co-S, thresholds for a critical customer segment. While the immediate pressure is to meet the quarterly targets, you suspect the data might be artificially smoothed, or that certain edge cases are being excluded from reporting to present a more favorable picture. You have a strong ethical conviction that accurate reporting is paramount, even if it means acknowledging underperformance. What is the most professionally responsible course of action? Option A. Adjust the reporting parameters to exclude the problematic data points, ensuring that the reported CO-S metrics meet the agreed-upon thresholds for the quarter. Option B. Ignore the suspected anomaly, assuming it is a minor fluctuation that will resolve itself in the next reporting cycle, and focus on meeting the targets through other means. Option C. Inform the affected customer segment directly about the potential data discrepancy and the reasons for it, without first consulting internal management or the CO-S oversight team. Option D. Immediately escalate the suspected data anomaly to your direct manager and the CO-S oversight team, requesting a thorough investigation into the data collection and reporting methodology, while refraining from any adjustments to the current reporting. Correct answer is D. Immediately escalate the suspected data anomaly to your direct manager and the CO-S oversight team, requesting a thorough investigation into the data collection and reporting methodology, while refraining from any adjustments to the current reporting. Explanation. This scenario presents an ethical dilemma concerning the integrity of quality of service, CO-S, reporting, and its potential manipulation. The professional challenge lies in balancing the pressure to meet performance targets with the obligation to provide accurate and transparent data. Misrepresenting CO-S metrics can lead to customer dissatisfaction, erosion of trust, and potential regulatory scrutiny, even if not explicitly covered by a specific 4A0-107 regulation. The underlying ethical principles of professional conduct and data integrity are paramount. The correct approach involves immediate escalation and transparent communication. This upholds the professional duty to report accurately and ethically. By raising concerns through established channels, the individual ensures that the discrepancy is investigated by appropriate parties, preventing potential harm to customers and the organization's reputation. This aligns with general professional ethics that prioritize honesty and accountability in data reporting. An incorrect approach would be to ignore the discrepancy or attempt to fix it without proper authorization or investigation. Ignoring the issue constitutes a failure of professional responsibility and could lead to continued misrepresentation of service quality. Attempting to manipulate the data, even with the intention of meeting targets, is a direct breach of data integrity and professional ethics, potentially leading to severe consequences if discovered. Another incorrect approach is to only report the issue internally without considering the broader implications for customer communication, which might still leave customers unaware of potential service degradations. Professionals should employ a decision-making framework that prioritizes ethical conduct and data integrity. This involves 1. Recognizing and documenting any discrepancies. 2. Consulting relevant internal policies and ethical guidelines. 3. Escalating concerns through appropriate reporting channels, such as a direct supervisor or a compliance department. 4. Advocating for accurate data and transparent communication with stakeholders. Question 20. Regulatory review indicates a network engineer has identified a subtle misconfiguration in an Alcatel Lucent network that, while not currently causing a service outage, has the potential to negatively impact the quality of service for specific traffic classes under peak load conditions. The engineer is under pressure to meet project deadlines and avoid any actions that might be perceived as causing instability or delays. What is the most ethically sound and professionally responsible course of action? Option A. Attempt to rectify the misconfiguration independently and without formal documentation or authorization to avoid raising concerns. Option B. Immediately document the misconfiguration and report it through the established internal incident management and change control procedures. Option C. Inform a trusted colleague about the misconfiguration informally, hoping they might address it without official escalation. Option D. Defer reporting the misconfiguration until a more significant issue arises or until the current project deadlines are met. The correct answer is B. Immediately document the misconfiguration and report it through the established internal incident management and change control procedures. Explanation. Scenario analysis. This scenario presents an ethical dilemma where a network engineer, responsible for ensuring quality of service, CO-S in an Alcatel Lucent network, discovers a potential misconfiguration. This misconfiguration, while not immediately causing a service outage, could lead to subtle but significant degradation of CO-S for certain critical traffic types under specific load conditions. The challenge lies in balancing the immediate pressure to maintain operational stability and avoid potential client dissatisfaction with the long-term responsibility of upholding service integrity and adhering to CoS standards. The engineer must decide whether to flag the issue, potentially causing short-term disruption or scrutiny, or to delay reporting, risking a more significant problem later. Correct approach analysis. The correct approach involves immediately documenting the observed anomaly and reporting it through the established internal channels, adhering to the company's incident management and change control procedures. This aligns with the principles of professional responsibility and ethical conduct expected of network engineers. Specifically, it upholds the commitment to service quality as mandated by the principles underlying CoS frameworks, which aim to ensure predictable and reliable network performance. By proactively reporting, the engineer demonstrates integrity, transparency, and a commitment to preventing potential service degradation, thereby safeguarding client trust and the company's reputation. This also aligns with the spirit of regulatory compliance, which often emphasizes proactive risk management and timely issue resolution. Incorrect approaches analysis. One incorrect approach is to ignore the anomaly, assuming it is minor and unlikely to cause significant impact. This fails to uphold the professional duty of care and the commitment to maintaining optimal CoS. Ethically, it represents a dereliction of duty, as it prioritizes convenience over the potential for future service disruption. This approach could lead to a breach of service level agreements, SLAs, and violate the implicit trust placed in the engineer to manage the network effectively. Another incorrect approach is to attempt to fix the misconfiguration without proper documentation or authorization. While seemingly proactive, this bypasses established change management processes, which are crucial for maintaining network stability and accountability. Such unauthorized changes can introduce unforeseen issues, complicate troubleshooting, and violate internal governance policies designed to ensure controlled network evolution. It also undermines the transparency required in network operations. A third incorrect approach is to report the issue to a colleague informally without following official incident reporting procedures. This lacks the necessary formal documentation and tracking, making it difficult to monitor the resolution progress and potentially leading to the issue being overlooked or forgotten. It also fails to involve the appropriate stakeholders who are responsible for assessing and rectifying such problems, hindering a coordinated and effective response. Professional reasoning. Professionals facing such dilemmas should employ a structured decision-making process. First, they should clearly identify the potential risks and impacts of the observed anomaly on CoS and service delivery. Second, they should consult relevant internal policies, procedures, and documentation related to incident management, change control, and CoS standards. Third, they should prioritize transparency and communication, reporting the issue through official channels with all available details. Finally, they should collaborate with relevant teams to assess the situation, determine the best course of action, and ensure proper resolution and documentation. This systematic approach ensures that decisions are informed, ethical, and aligned with professional responsibilities and regulatory expectations.